Hello and welcome to Partial Fractions Expansion MATLAB tutorial. This tutorial describes several features of MATLAB that can be used with Laplace transforms. MATLAB contains commands that simplify the process of completing a partial fraction expansion. The primary command that we use for the partial fraction expansion is of the form rpk equals residue num den, where num and den are vector representations of the numerator and denominator polynomials respectively. The residue function returns three vectors r, p, and k. The vector p contains the poles of the function's roots of the denominator. The vector r contains the residues corresponding to each of those poles, or the coefficient that goes into the numerator of the partial fraction corresponding to that pole. The vector k contains the direct terms and will only be non-zero if the degree of the numerator is greater or equal to the degree of the denominator. In order to perform a partial fraction expansion, f of s equals to s minus 2 over s squared plus 3s plus 2, the following command rpk residue is used, which gives us the following answer. This means that f of s has poles at -2 and -1 with the corresponding residues of 4 and -3 respectively. Also, there is no direct term. Thus, the partial fraction expansion is of the form f of s equals to 4 over s plus 2 minus 3 over s plus 1. For the transform, f of s equals to 2s squared plus 7s plus 2 over s squared plus 3s plus 2. Using the residue command, we get the following. The results are the same as in the previous example, except that there is a direct term k equals 2. It tells us that there is a constant of 2 in the partial fraction expansion, or f of s equals to 2 plus 4 over s plus 2 minus 3 over s plus 1. For the Laplace transform, 3s squared plus 4s plus 4 over s multiplied by s plus 1 multiplied by s plus 2. Before we can apply the residue command, we need to multiply out the denominator. The conv command in MATLAB multiplies polynomials in the form conv a comma b, where a and b are vectors with the polynomial coefficients. For example, conv 1, 1 and 1, 2 multiplies the polynomials s plus 1 and s plus 2 and results in the polynomial s squared plus 3s plus 2. The partial fraction expansion can now be found with the following rpk residue command. Which corresponds to a partial fraction expansion. F of s equals to 4 over s plus 2 minus 3 over s plus 1 plus 2 over s. This concludes our tutorial. Thank you for your attention.